Okay, this is Math 2. We're going to do 78 through 84. And to start us off on 78, it says the table at the right shows the height of an acrobat. As she practices a trick on a trampoline, she reaches a maximum height of 16 feet above the trampoline. So 1.0 seconds after she's 16 feet in the air. What is the average velocity of the acrobat between 0.25 seconds and 0.5 seconds? Include units in your answer. So the actual hint online is actually pretty good. It says, wait, I can't see anything. Hold on a second. Divide the difference of the heights by the difference of the times. So between 12 feet and 7 feet, so how much does she actually go up between 7 feet and 12 feet? She went up 5 feet. And between 0.5 seconds and 0.25 seconds, the time lapsed was 0.25 seconds. So if you divide 5 by 0.25, you should get 20 feet per second. So in that time frame, between 0.25 and 0.5 seconds, she actually was going 20 feet per second. All right, and then part B, what is the average velocity between 0.5 seconds and 1 second? You're basically going to do the same thing that you did in part A. How much distance was covered in that time frame, and the time that was covered was 0.25 seconds also. I'm sorry, 0.5 seconds between 1 and 0.5. And then what happened to the velocity of the acrobat as she approaches the top of her jump? Does this make sense? So if you actually graph this thing, which isn't that really hard to do. So if you actually graph this, the height of her jump, which is around 16, was at 1.0. And then at 2.0 seconds, she came back down again. So she went up at 16, that's her highest point, and then came back down again. Okay, that's a horrible parabola, but you get the point. She should be slowing down somewhere up here. As she's coming closer to the, slows down a bit. She should be slowing down somewhere up here, and then reaches the top of her jump. She's still slow, but she's actually going in a negative direction here. And then as she gets closer, she speeds up. All right. Does this make sense? Well, it should, because you're going really fast high up, and then you max out at 16, and then you're speeding up back down again. All right, 80. Copy the graph at the right onto your graph paper. If the shape is ABCD was rotated about the origin 180 degrees, where would A prime be? So we're going to use a pencil. Now, if you've never actually done this on graph paper before, please do it on graph paper, because it would make your life so much easier if this was on graph paper. So this is point E, this is point A, this is point B, this is D, and this is C. Okay, so here's the actual. I'm just going to lightly draw this in. Okay, there's A. Here's B. Did I draw this on the right side? Oh, I totally just not do this on the right side. Okay. Oh, that's better. Okay, so we're going to rotate this 180 degrees. I'm assuming about the origin. Yeah, okay. 180 degrees means 2 rotations. All right, well, in any direction, it really doesn't matter. If you go this way, 1 rotation, and you go this way, another rotation, you end up in the 3rd quadrant. Okay, if you're back at the original and you go to the right, 1 rotation, and then another right, well, then you're still down in the 3rd quadrant. So any which way you do it, you still end up 180 rotation ends up on the 3rd quadrant. So A prime is now going to be where A was originally. So it's really at -1 and -2. There you go. So that's A prime. If the shape ABCD was reflected across the x-axis, so if you take this shape, this is your x-axis, right? Well, I'm going to reflect it I'm going to flip it over the x-axis. So where's C prime going to be? So that means C prime was originally came from C. So C prime is now going to be at 1, 2, 3, 4 and -4. Okay, and the last one, if A, B, C, D were translated so that each point x, y corresponds to x minus 1 and x and y plus 3, where would B prime be? So x minus 1 means we're going to go subtract all the x's by 1. So that means we're going to go x minus 1. Okay, this is not like a parabola. Please don't confuse this x minus 1 with what happens in a parabola. We're not going to go to the right. We're actually legit going to go to the left. So we're going to go 1 to the left, okay, because we're subtracting all the x values by 1, and then we're going to go up 3. So 1, 2, 3. So that means B prime is going to end up going somewhere up here. So 3, right, because we just subtracted 4 by 1, so that's 3. And then added 3, so we're going to be at 2, 3 from 1, which should be at 4. So we're going to be at 3, 4. Okay, all right, so that was 80. 81. Given the quadratic, sorry, I skipped 79 on purpose. It's really easy. You should be able to figure it out. Given the quadratic function x squared, write an equation for each transformation below. Describe how the transform graph would be different from the original graph. So this is a really good thing to put on a group test, and I'm actually thinking about it. So heads up. So we have x squared as your function, right? The original graph of x squared, I'm going to just do it really quickly. So, right, it goes, here's your parent graph. It's not the best drawn, but it does the job. Okay, we have y equals x squared. Or in this case, sorry, my bad, f of x equals x squared, because since we're doing function. So f of x equals x squared, write an equation for each transformation below. So if f of x is technically your x squared, then what does x squared minus 2 actually do to the graph? Well, it's not in the parentheses, so x squared minus 2 would transform your graph, or you would shift your graph down 2 units from the original. So technically a transformation would go from the origin, it'd go down to -2, and then it would go up. Just like that. Okay? So please write that down as a sentence. What did it do? And then the next one, 2 times f of x. So it would be equal to -2 times x squared. All right, well, -2 basically tells me it's going to get a little skinnier, and then the negative is basically going to tell me it opens down. So it's going to be a down-turning, slightly skinnier version of the original. Okay. F of x minus 2. All right, so then we have, in parentheses, x minus 2 squared. So if I remember correctly, subtracting a 2, x minus 2 inside the parentheses, tells me in a parabola, in a quadratic equation, that we have to go to the right 2. So we're going to shift it 2 units to the right, and it's pretty much just the original parent graph is just shifted 2 units to the right. And then the next one is f of 2x. So we're going to say, oh, okay, well then 2x squared. Yay. Okay. And then this one, I actually have to look up because I can't remember what this thing looks like. So hold on just a second. Good old Desmos to the Rex skew. Graphing y equals 2x to the second power. Oop, I should probably put that in parentheses. There we go. Oh, it's just the skinnier version. Anything special? No, not really. It pretty much just looks almost the same. There you go. Alright, so please describe those transformations in words also. 83. Review what you know about angles of the polygons below. It's a good thing you're reviewing it because you're going to see it on a group test. So that's good. If the exterior angle of a polygon is 29 degrees, what's the interior angle? So I guess if you draw like a rough sketch, let's say you have a polygon, right? You have a bunch of sides to it. I'm just going to draw like kind of the edge of it. So an exterior angle would be, so sorry, your polygon is this one right here. So let's say I'm zooming in on a polygon, right? And your exterior angle is 29 degrees. It's coming out from this side right here. Well, how much is this interior angle then? So if that's 29 degrees, what's this amount right there? I'm going to let you figure that one out. By the way, it's on the line, in case you wanted to know. Okay, the next one. If the interior angle of a polygon is 170 degrees, can it be a regular polygon? So if you have some random sided figure polygon, right? You have a bunch of sides. They're all equal sides. That's the part with the regular you have to remember. A regular, everything has equal sides. Will you be able to create an interior angle that's 170 degrees right here? That's the question. So, I mean, you're really going to need a calculator for this one. Can you ever split this up? You know, let's say it's, I don't know. Actually, there's a faster way to do this. If this interior angle was 170, then out here it should be 30. Out here it should be, oh, I can't believe I did that, 10 degrees, right? Because interior and exterior add up to 180. So if this is 10 degrees, that means 360 divided by 10 should give you a, let's say, what is that? 36-sided figure. Nice. Okay. So it's a 36-sided figure, and you can check. 36 minus 2 times 180. So that's 34 times 180. 34 times 180 is, let's see, what is this? 34 times 180 is 6120. 6120 divided by 36 sides gives you 170 degree interior angle. So all of these angles are 170 degrees, which is a very weird circle. I mean, a very weird polygon. It probably almost looks like a circle. Okay, determine the sum of the interior angles of a 29 gon. Oh, that's easy. Just minus 2. So 29 minus 2 times 180. So that's 27 times 180, right? Whatever that is. You do the math. And then the last one. Yay! If the spinner at the right is spun 80 times, how many times do you predict it will land in each region? Show your work. Okay, so this is obviously 90 degrees, right? 90 degrees, 135 degrees. If you add those up, take away from 360, you should get 135 degrees for that one right there. Okay, so each region has a different probability because obviously not every single region is the same shape, except for B and C, but A kind of ruins it. So 90 out of 360 gives you 9 out of 36, better known as 1/4. So 1/4 is the probability of getting region A. B, or region B, is 135 out of 360. And C has 135 out of 360. So each of these have, that's 1/4, 135 out of 360 is whatever the probability is. And the way you find out if it's spun 80 times is you just multiply it by 80. So 1/4 multiplied by, I shouldn't do it over there. So I have 1/4 multiplied by 80, right? Means, if you do that correctly, so 80 divided by 4, 20. So that means if you spin the spinner 80 times, 20 of the times that you spin it, it should land in region A. And you need to find out how many times would it land in region B, how many times would it land in region C. All right, so that's what the 20 means. It means 20 times. If you spin it out of the 80 times, 20 of those times it should land on region A. All right. Okay, that's it, basically. So that was 78 through 84, and I will see you guys tomorrow. And you need to finish the rest of this up, too.